have we been learning about these past few weeks in math class? What? Fractions. Okay, so where have we seen fractions? Jalen?
I was concentration. We've seen them. What do you mean by that?
Okay, what do I mean by that? I mean that where have we used fractions, or where have we seen them? What have we used to model fractions?
We've used the number line.
Okay, we've seen fractions on a number line. Kinley?
We have used brownies.
Brownies.
Paper brownies.
Paper brownies to be exact.
I'm going to say what
You're going to say what Kinley said. We've also used fraction tiles and those hexagon cookies, remember?
and those things that says that they're threes, and then you put them together and you can make different fractions with them.
Yes, yes. So what we're going to do is we're going to look at the task that you've been working on, and we're going to discuss how you have compared them. Okay? So if you'll get your task out and reread number 1. Sally has 3/4 of a cheese pizza and 2/4 of a pepperoni pizza. Which does she have more of, the cheese pizza or the pepperoni pizza? So tell me about these two fractions. What do you notice?
I kind of have like one question about if you had these two fractions together, I still kind of wonder what I would have.
Okay, so let's hang on to that question. I like that question because that's where we're going next. But let's first look at what do you notice about these two fractions? Jalen? Jalen?
I'm sorry. The two denominators in both of these fractions are the same.
Okay, both of the denominators are the same. So what does that mean we have to do to compare them?
We're going to have to look at
Kinley?
We're going to have to look at the numerators.
We're going to have to look at the numerators. So if I'm going to try to show, and I know you have your representations there, if I'm going to show 3/4 and 2/4, can you walk me through how to do that? How can I show 3/4?
You could draw a rectangle and divide it into equal fourths and shade in through.
What does the denominator tell me? Thorn?
How many pieces are in the whole? Not pizzas.
That'd be nice, wouldn't it? How many pieces are in the whole? And so what does the numerator tell me? Kinley?
How many pieces are being shared?
How many pieces are either being shared or how many pieces we're talking about? Okay. So Hunter, you did a great job telling me how to represent 3/4. What about 2/4?
Do the same thing that she does to the first one, but you don't shade in 3, you shade in 2.
So if I asked you to compare these fractions, 3/4 and 2/4, how would you compare them? Thorn, how would you compare these two fractions?
Since the denominator is the same, since that one had a 3 in the numerator, that means more pieces are being talked about than the other one, which are 2's in the numerator.
So what could you say about 3/4 and 2/4? Kinley?
That 2 is only being shared in 2/4, and 3 are being shared in 3/4.
So what could we say now that we know how many pieces are shaded, how many pieces we're talking about?
Wait, I think that I could say that I think that maybe 3/4
2/4 is the answer? Okay, what do you think?
I agree with that.
Okay, agree. What do you think? What do you think? Okay, so why? Why is this, why do you think 3/4 is greater than 2/4? Why do you think 3/4 is greater than 2/4? Kinley?
Because there is only one piece left in the 3/4, and in the 2/4 there are 2 left over.
So what sort of statement can you make about 3/4 and 2/4? What symbol could I put here? Jalen, what do you think?
I'm so sorry. The greater sign.
The greater sign. So if I put that there, Thorn, how could I say that?
3/4 is greater than 2/4.
Can you repeat that, Hunter? Or how can I say this?
3/4 is greater than 2/4.
All right. So as I'm getting ready for the second one, if you'll reread the second question, we'll talk about those two. Would you reread it?
Yeah.
Mary and Dominic have the same size pizza, but their pizzas are cut differently. Mary has 2/6 of her pizza. Dominic has 1/3 of his pizza. Show their pizzas. Who has the most pizza and how do you know? So who can share with me how they're going to represent 2/6? Jalen?
Okay, so draw a square. Then you need to draw 6. Okay, get that up.
Okay.
Okay, then you need to shade in 2.
That looks like your representation, yours, and almost yours. You've got a little bit to add to that, and looks good there. All right. How am I going to represent 1/3? Kinley?
You're going to draw another square the same size as 2/6.
Hang on one second. We're going to draw the same size pizza. Why?
Because if you're going to make a huge one and have a real small one, it's not going to, you drew on the 2/4, you put a huge 2/4 and a small 3/4, you're going to get the wrong answer, and you're going to put a greater sign to the 2/4.
And then the problem says same size pizza too, doesn't it?
Yeah.
Okay, I'm so sorry. Go ahead.
You're going to draw 3 pieces, and you're going to shade in 1.
So what are we thinking about these two fractions, 2/6 and 1/3? Jayla?
I'm thinking what I just noticed is the denominator on the 1/3 and the denominator on the 2/6. The 1/3 doubles up to the 6.
So we see some relationships and connection here, don't we? Okay. So what do you think about when you compare, when we're comparing and looking at these two fractions? Kinley?
I don't know, but maybe they might be equal because that actually fills in that. And so,
What do you think, Thorn?
I agree.
You agree?
I'm still a little confused.
We're still a little confused, that's fine. Okay, so we know there's a relationship here. You saw that 3 doubles to get 6, so the denominators have a connection. What about the numerators? Jalen?
It's 1 plus 1 equals 2, so it's also a double.
Okay. Kinley?
I see it again. That is equal to that.
You think it's equal to that? What do you think, Hunter? You agree with Kinley? So let's get out. I'm going to model with fraction tiles, and I want you to see if this confirms your answer or your thoughts, and then we'll talk more about it. Okay, so do you agree that that's 1/3?
Yes.
And I put 2 6. What do you notice?
That 2 of 1 6 equals 1/3.
Equals 1/3. Any other relationships or connections you can see between 1/3 and 2 6? Jalen?
The reason I just laughed is because I made a connection. It all has one that's a numerator.
These do all have one that's numerator, but then if we look at how many sides of the same piece, this would be 2 6. So let's look at this. What do you notice about the relationship between 1/3 and 1 6? Jalen?
1 6, well, takes kind of half. Like if you do 1 6, it takes up half of the 1/3.
And what were you going to say?
I was going to kind of also say that 1 6 equals half of 1/3.
1 6 equals half of 1/3. Then when we have 2 6, it equals 1/3. Does it help looking at these different models and looking at the relationships between the two fractions?
Yes.
Which fractions were easier to compare? 2/4 and 3/4, or 2 6 and 1/3? What do you think?
To me, I kind of thought they were both the same, but there is kind of a difference.
There is kind of a difference. Let me write these fractions here so I can put back what we compared before. So which of these were easier to compare? 3/4 and 2/4, or 2 6 1/3? Finish your thought.
I thought that I think that maybe Sally's was easier.
Sally's
because you're
were
not
easier.
having to use, like, they're kind of the same.
Okay.
Like, I don't know how, they're kind of.
Kinley?
I think 2 6 and 1/3 is easier.
Why?
Because, like you could tell that was equal to 2 of the 2 shadeds of 6.
What do you think? These 3/4, 2/4 easier, or 2 6 and 1/3 easier?
For me, the 3/4 and the 2/4 were easier because the denominator is the same, so the numerator is greater, that fraction will be greater.
Do you see that too?
Yeah.
But that's great too, that you're able to see that and make those connections and find equal fractions. Any questions we have about these two? I know you've got a question that we're going to look at in just a few minutes. Jalen?
I kind of had the same question as Thorn, and I'm still a little, confused about, I could see the connection of how they look the same. I'm still just a little, just a teeny bit confused of how they are still equal.
How they are still equal. And you had pointed out, I think, that the relationship between the denominators and the relationship we found between the numerators. If you take, I have my whole here, and I'm going to put all the thirds out. This one whole, do you see how it's divided into 3 equal pieces?
Yes.
Okay. And then to make one whole, how many 6 are we going to need? 6. That makes sense. If you divide a brownie into 6 equal pieces and you eat all 6,
Sometimes
you're
I
going to eat
just
one
have
whole
to
brownie.
see it.
Well, that's why we're doing this, right? Absolutely. It possibly could. Alright, so now, that's why we always need to look at our one whole. We always need to have our one whole present. That's what we start with when we draw them. That's what we really need to start with our fraction tiles, number line. Okay? So if we look at this, it does take, how many thirds does it take to make one whole? 3. No, you're okay. It takes 3/3 to make one whole. Well, because of our multiplication work, there's a relationship between 3 and 6. What's the relationship between 3 and 6?
3 is a double to
Is a double to 6. How could you say that in a different way? The relationship, if you double 3 to get 6, how could you get 6 to go to 3?
I was thinking of 6 divided by 3 is 3.
What is 6 divided by 3? It's not 3.
What, yeah,
If we're thinking, if we know that 3 times 2 equals 6, 6 divided by 3 equals 2. Okay? So if we know that, how many 6 is it going to take to make 1/3?
2. Yeah, 2.
2. Okay, but that helped seeing this visual here. Okay. We're still going to work on comparing fractions and finding equivalent fractions and looking at the relationships greater than and less than. Okay. All right. Thank you all, and we will continue looking at other task work and looking and diving deeper into more fractions.